introduce a couple more terms in order to characterize what's going on when you have a linear graph or a linear function. Okay, so let me just recap a little bit. So when we have a line, that means that our function, our f of x or our y or whatever, starts at a certain value. So this starts meaning x equals 0, when your input is 0, at a certain value. Okay? And that value happens to be our y-intercept, which is our b. Okay? Alrighty. So then, and then after that point, and before that point too, then starts changing, and then it changes, we could say, at a constant rate. At a constant rate, m, our slope, as x increases. Okay? And decreases too. We can't forget the going to the left either. Okay? And as we'll see that, and as we saw previously, the m, the slope, this is important to note, slope or rate of change of a line, and specifically for a line, is constant, or the same, you could say, is constant / the same anywhere on that line. Anywhere and everywhere on that line, the slope stays constant, okay, on the line. Alrighty, so 3 important classifications to make is that if your m is greater than 0, okay, so our slope is positive, that means as we move to the right in x, as we increase our input, our function value goes up, okay, so that would look like this. So as we increase our input, function value goes up, so our line would look like that. It would have an upward sloping kind of thing going on, so an upward slope basically. So that means that our f of x is increasing, okay. Alrighty, conversely we have if m is less than 0, that means as we move to the right, our function values are decreasing, so our line would look like this, and we have a downward sloping thing, okay? So this would mean that f of x is decreasing. If, on the other hand, m is equal to 0, that means as we move to the right, our function values do not change. They just continue on and they're constant kind of thing. So that means that our line is actually going to be horizontal. So horizontal line, we have horizontal line, and f of x is neither increasing nor decreasing. Okay, instead it's just called constant because it stays a constant value. Alright, so let's do an example of linear functions, utilizing linear functions. So we have, Marcus currently owns 200 songs in his iTunes collection. Every month he adds 15 new songs. Write a formula for the number of songs n in his iTunes collection as a function of the number of months m. Okay, how many songs will he own in a year? Alright, so let's work through this step by step. So we have, well, currently, that means right now when m, and okay, it's a little bit confusing because they have m here, and that doesn't represent the slope. M is just the variable, okay? So m is the variable representing number of months that have passed. Number of months from today, or from currently. So that would be from today, right? So today would be represented by m is equal to 0. This represents today or right now, or this month, okay? And next month would then be m equals 1, and etc., etc. So this would be like next month, okay? So right now, meaning m equals 0, which means today, we have that n, so we could say they told us write a formula for the number of songs n, capital N. So n is our function of m, okay? So when n is n of 0, okay, I'm going to get rid of that equal sign. So when we have n of 0, that means n, which means number of songs today that he has. We would look back at our question, right? And it says he currently owns 200 songs. So n of 0 is going to be equal to 200 because no months have passed. We're talking about today, right? So that would be m, as in mouse. M is equal to 0, and the number of songs is equal to 200, right? So this is what's called like an initial condition kind of thing, okay? So we have this information so far, which means in terms of like linear functions and everything, 200 is equal to our y-intercept, right? Because when our input was 0, this is what we got. So this is like our b, Okay? And now our job is to find, okay, what is slope? And I won't use m because we already used m for our variable. So what is slope? This is, remember on the previous slide, when I was introducing slope, I said, well, that's basically how much our function changes with each 1 unit increase in the input, or in the dependent variable, right? So as m goes up, goes up by 1, as it increases, so each month, how much does his n, the capital N, change, right? And so let's look at the next sentence. It says every month, so per 1 month, he adds 15 new songs. So that means the total number of songs that he owns is going to increase by 15 each month, okay? So we have 15 new songs per 1 month, right? So this, in fact, is going to be our slope. So our slope is going to be equal to 15 songs, that is, over 1 month. Okay? So we found our slope, and now we'll just plug it into into the slope formula. Okay? The slope-intercept formula. So that would be y is equal to mx plus b, this kind of form, but instead we'll write it in terms of n and m. Okay? So if we convert that into this term, it would be n of m is equal to, and instead of that, I'm just going to write slope times m, where m, I know this is a really confusing thing, but m here is our variable, right? Remember that means number of months. Number of months, just as a refresher. So this one here that the arrow is pointing at is not our slope, okay? Plus b, whatever b was. Alrighty? So we're just going to plug those in. So in for slope, we're just going to plug in a 15. And in for b, we're just going to plug in 200. Alrighty? So let me write the result on the next slide. So we have n of m is equal to 15m, number of months, plus 200. Okay? Because remember, we started at 200. That's what he currently owns today. And then we add 15 every time a month passes. That's basically all it means, right? So the question was, how many songs will he own in 1 year? From today, that would be. Okay? So 1 year is equal to 12 months, right? So 12 months. So that means that we want to find what is n of 12. Okay? And in order to do that, we just plug in a 12 into our equation, and we go on our merry way. So n of 12 is equal to 15 times 12 plus 200, okay? And 15 times 12 is a 180. So we have 180 plus 200. That's going to equal 380. So Marcus will have 380 songs by the time a year has passed, okay? Okay, here's one more example we'll go over before concluding this video. So we have, given f of 3 is equal to negative 2, and f of 8 is equal to positive 1, find an equation for f of x. Okay, so you might be thinking, how am I supposed to do that? Don't worry, I will explain how to do this. Okay, so they gave us basically, or essentially, 2 points for our function, okay? So this one means when we plug in a 3, we get out an output of negative 2. Okay, and this one means 8, 1. All right? So, building off of this, we've kind of seen this earlier on in the video, where you can find slope given 2 points, right? You can find the slope between 2 points given this formula, m is equal to y2 minus y1 over x2 minus x1, okay? And like I said before, it doesn't matter which one you make to be the first point or the second point, it'll all turn out the same, okay? So just for kind of consistency, I'll just make this x1, y1, and this one's x2, y2. Okay, so let's calculate the slope between these two lines, alrighty? So this one's going to be, y2 would be 1 minus a negative 2, and then this is going to be over 8 minus a 3. So this is 1 plus 2, actually, right? So that would be 3 over 5, okay? So our slope is 3 over 5. Okay, so this is equal to our slope. And now you might be thinking, well, how do we get to our y-intercept? I know that's where, when our input is 0, but how do we do that? So the answer would be, well, let's just write out what we know so far. So y, or f of x, we could write, f of x is equal to slope, so 3 over 5, times x plus b, okay? So now it's like, well, all right, so how do I find b? Because now I have this guy this guy, and this guy that I don't know. But the thing is, yes, we can utilize any point that we do know that lives on our line, that exists on our line, right? So let's take, for example, we'll use 8, 1. Okay, this is a point on our line, right, where the x value is 8 and the y value is 1. All right, so what we're going to do is plug this into the equation that we have so far, and we're going to solve for our b. Okay, so let's do that on the next slide. So we have f of x is equal to 3 over 5, that's a 3 on top there, x plus b, and we're going to use the point 8, 1. So this is our x and that's our y, or our f of x. Okay, so let's plug those in. We get 1 is equal to 3 over 5 times whatever our x value we're plugging in, plus b. Okay, we're just going to plug these in. So 1 is equal to 24 over 5 plus b. We're just going to subtract this fraction over. So we get 5 over 5, which is 1, minus 24 over 5 is equal to b. So then here we just get a negative 19 over 5, which is pretty ugly, but that will be the y-intercept. Okay, so there it is. We just solved for b by plugging in a point on our line that we already knew. Okay, so now we can put together the entire equation of our line. So we're going to get that f of x, which can also be denoted as y, is equal to 3 over 5, which is our slope, x, and then plus b, so that would just be minus a 19 over 5. Okay, and that is it. That's the equation of our linear function. Okay, that concludes our concepts video on linear equations and functions. I hope that helped, and I'll talk to you in the practice problems video if you watch.
But I can't help myself.